Similar solids have the same shape and all of their corresponding dimensions are proportional. So we've been doing two-dimensional shapes and seeing if they're in proportion, but you can also do three-dimensional shapes. So the same situation applies where I would take one of the shapes and then write the sides from least to greatest, so 4, 6, 8, and then do the same with 4 matches up with 7, 6 matches up with 10.5, and 8 and 14 match up. So if they are similar, all of these are equal. So check to see if they are. Yes, they are. So that means the similarity ratio is 4/7. For this cone, I'm going to do 4, 8 on the top, and then 4 corresponds to 3, and 8 corresponds with 6. So is this the same? Yes. So the similarity ratio is 4:3, first to second, or 3:4, depending if it tells you to do first figure to second figure. So remember back in chapter 10 that if you had a similarity ratio of A to B, then the area ratio is A squared to B squared. Well, our volume ratio is going to be A cubed to B cubed. So example 2 is, find the similarity ratio of the smaller figure to the larger figure. So this smaller figure has an area of 49, and this one has an area of 81. So this is small, this is the larger one. So I'm going to write 49 to 81, but this is area. So to get the similarity ratio, you need to take the square root. So it's 7 to 9, or 7/9. And then over here, we have volumes. So if I'm going to compare this volume to this volume, first I need to do the similarity ratio. I need to take the cube root. So third root. So first I see if I can reduce this, and I can't. So I'm going to do the cube root. So the cube root of 125 is 5. The cube root of 512 is 8. So it's 5/8, or 5/8. So area, you need to take the square root. Volume, do the similarity ratio, you need to take the cube root. Okay, and the next part, the surface area of two figures are given. The volume of the larger figure is given. Find the volume of the smaller figure. So what we need to do is find the similarity ratio right here using these two. So if you have 25/36, the similarity ratio is 5/6. So if I'm comparing volumes, I need to cube the similarity ratios. So I'm going to do 5 cubed over 6 cubed. Now the directions read to find the volume of the smaller figure. So that means that this one, 216, needs to go where the greater number is. So I'm going to put 216. And then X on the top. So now I'm going to cross multiply. So I'll get, when I solve this, you can work it out, but I get actually 125 centimeters cubed. So I did 5 cubed times 216 and divided by 6 cubed. And then so number 7, I'm going to do it again. I need to find the similarity ratio first. So to find the similarity ratio, I take the square root of the area ratio and get 4/5. But then we're talking about volume, so I need to cube these, and then I want the smaller figure, so I put 500 on the bottom. So when I cross multiply and solve, I get X equals 256, and we want to talk about volume, so it's inches cubed. And then the last one, again, I want to compare these, so it's 72/98. And let's see. I can divide, I'm going to break down the square roots. So if I take the square root of this is 7 root 2. Nope, that's not 7 root 2. This one's 7 root 2. This one is 6 root 2. These two cancel out. I probably did that a weird way. So I know the volumes are 6 cubed over 7 cubed. 686 needs to go down here. This is x. And I cross multiply and I get x equals 432 feet cubed. Okay, then down here is similar. So, but this time we're given the volume and we need to find the surface area. So we're given the volume ratio. So in order to find the similarity ratio, you need to take the cube root. So the similarity ratio is 2/5. But I'm comparing the area ratio, so I have to square these. Find the surface area of the larger figure. That means that this goes with the smaller figure. So this is 4 over x. Solve for x. X is 25 feet squared. So the next one, you have volumes. So to compare volumes, you do the cube root. So you're having 40 over 135, but then you're going to take the cube root of each. Alright, and then off to the side, remember doing that cube root of 40? You break down 40, 8 and 5, 2 and 4, 2 and 2. Cube root of 40 is going to be a 2 on the outside, cube root 5 over, and then 135 is going to be 3 cube root 5, choo-choo, so it's 2/3. So I guess this is an example of reducing, because I should have reduced this part first, but I could do it without it. So my similarity ratio is 2 to 3, and I'm comparing the areas, so we need to square these. So it's 2 squared to 3 squared equals, I want to know the larger figure, so it's going to be x, and I know the smaller one is 40. So when you cross multiply and divide, you get x is 90 meters squared. So I'm not going to do this one, it's very similar, but your answer, and you can look at my notes online, is 300 centimeters squared. Okay, so last one. A cone-shaped pile of sand weighs 250 pounds. So weight is going to have the same ratio as volume. Okay, so this pile weighs 250 pounds. So how much does a similarly shaped pile of sand weigh? So think about volume. What's the volume going to do if you increase each dimension by 6 times as large? So pretend that we extend this out 6 more times and this cone goes 6 times as big. You can see that it's going to be huge, so much bigger. So what's going to happen is if the dimensions are 6 times as large, so you're going from 1 to 6, but it's volume, so you're actually going from 1 cubed to 6 cubed. So you're multiplying it by a factor of 216. So it's going to be it's going to be multiplied by 216. So it's 250 times 216. and that is 54,000 pounds. Much bigger when you do each dimension by 6.